Reading from an array takes the same time no matter where you look. Inserting into that same array can be instant, or it can grind through thousands of operations, depending entirely on where you insert. Same data structure, same array, wildly different cost. Here's exactly why. Last video we covered what arrays are and touched on this trade-off briefly. Today we're going deep into the actual mechanics. The real reason indexing is O1 and insertion isn't, so you can explain it confidently in any interview, not just recite it. Every value in your computer's memory sits at a specific address, basically just a number, like a street address for a house. When you create an array, your computer reserves a block of consecutive addresses, one right after another, no gaps. Here's the actual formula your computer runs when you write array. Start address plus index times the size of each element. If your array starts at address 1000 and each item takes 4 bytes, array is at exactly 1000 plus 3 times 4, which is 1012. One calculation. No searching. That's why it's constant time. Insertion breaks the no gaps rule. If you insert a value at index 0, index 0's old value needs to move to index 1, the old index 1 needs to move to index 2, and so on, all the way down the array. Every single element after your insertion point has to shift to make room and preserve that gapless memory layout. Insertion isn't always O of n, though. If you're inserting at the very end of an array that has room, no shifting is needed at all. That's O of 1. Insert at the very beginning of a full array, and you're shifting everything. That's the true worst case O of n. Where you insert changes everything. Deletion follows the identical logic, just in reverse. Delete the last element, instant O1. Delete the first element, and everything after it has to shift left to close the gap, O1 cent. Same underlying reason. Arrays must stay gapless in memory. Here's the mistake that catches people in interviews. Saying array operations are ON as a blanket statement. That's wrong. It depends entirely on the operation and the position. Reading by index is always OS1. Insertion and deletion depend on where in the array you're operating. End is cheap, beginning is expensive. Precision here is exactly what separates a strong answer from a vague one. Array indexing is O1 because your computer calculates the exact memory address with one formula, no searching required. Insertion and deletion cost depends entirely on position, instant at the end, expensive at the beginning, because everything after the insertion point must shift to keep memory gapless. This is video 6 of the full DevVerseX Data Structures and Algorithms course. Subscribe so every concept keeps building in order. Next up, linked lists explained, the data structure that solves exactly the insertion problem you just learned about.